Alright guys, today we're going to do a LeetCode problem of the day for 841. It's called Keys in Rooms. The question asks, there are n rooms labeled from 0 to n minus 1 and all the rooms are locked except for room 0. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array of rooms where rooms I is the set of keys that you can obtain if you visited room I, return true if you can visit all the rooms, or false otherwise. So here we have rooms and we have a list of lists. So for room 0, if we go here, we can pick up the keys 1, and then so on. At room 1, we can pick up key 2, and at room 3, we can pick up room 3, and consequently receive the last room. So, let's see, 1, 3, 3, 0, 1, 2, 0. So, okay, so, okay, goal. The goal of this thing is to, basically, we are trying to say visit all rooms if determine if visiting all the rooms is possible. Inputs the rooms with keys inside each room. Output return true, false if visiting all rooms is possible. Alright, so let's talk about some pseudocode. So we ran through the examples. It's pretty straightforward. Here we have 1 and 3 in the first room. We enter here, we can enter 1, we can enter 3, and then, yeah. So we visit 3, and then we say, okay, 301, and so on. Can we visit anything else? No. Then we visit 3, we get a 0. Can we visit anything else? No. How many rooms did we visit, and is that equal to the length of rooms? So, determine how many rooms we have to visit. Keep count of number of rooms visited. Then we will, let's see, keep a set of rooms visited. How about that? Set of integers of rooms visited, so then we can count the length of that. Then we will DFS over, I guess we could BFS, right? BFS over, because it's essentially forming a tree, right? 0 connects to 1 and 3, 1 connects to 301, and 3 connects to 0. So BFS over the rooms. I guess a DFS would be, BFS works. Okay. All right. So we're going to do that. We're going to BFS over the rooms, and we're going to keep a set of the room visited. So n is equal to the length of the rooms. Let's talk about time complexity. Time complexity of this will be O of n, where n is the number of rooms. Space complexity will be O of n, because we keep a set of which rooms we have visited. Technically, this is an unordered set. And so, yes, n is equal to length of the rooms. Our Q is equal to this list here. We'll do collections deck. And then we will start with a 0f room. So visited. So we'll have visited is equal to set, and keys is equal to set at 0. Let's start with 0. So while q, so our room is equal to q.pop, so pop left, so that will be our 0. So visited, add our room, we'll say rooms at index. Rooms at the index for R and rooms at index. So for each room in the room's index, we're going to add that to keys, and we're going to say if are not visited, q.append r. Visited of add r. Okay, return n equals length of visit. So we've done what our pseudocode here is. We determine how many rooms we have to visit. We keep an unordered set of the rooms visited, keep track of keys we have. Actually, we don't even need to keep track of the keys, do we? Because we're not even checking it. So we just keep track of what we visited. We visited 0. And then for R and rooms, if R has not been visited before, that means we have a key for it because we're accessing it. Then we can append it and say, let's not visit it anymore. Okay. IDX equals q.pop left. And then we say, have we visited all the rooms? Okay, so we run this. Does not hit. Thought something was off. Okay. And that solves the cases. Let's come up with a couple more test cases just to be certain. So if I were in an interview, I already have a failing case. This is a failing case. I have a case where it's passing. How about a case where it should pass, but you have to access points from the same locations. So I have to access 1 and 2 from here, and then I can access 3. And just for certain, let's do here. Rooms return true. It looks like you have cases where there are no rooms, right? So rooms. Actually, there's always going to be at least 2 rooms. So we can go ahead and delete that. How about if both rooms are empty? And then, of course, if the 0 if room has access to the 1. One to 3,000 only. The values of rooms should be 1 to 3,000 only. Oh, so I must have a key. Right? And it passes. So this fails as expected, and this one returns true as expected. All right, so we submit this answer. We should have, yes, our result. So it beats 52%, memory is 87%. I'm guessing that these more efficient solutions are going to be a depth first search. Let's take a look at Lee's. So this is straightforward. He uses a stack for the DFS. And, I didn't know you can use a stack for DFS. So I is equal to pop, J, seeing DFS. Okay, that's pretty cool. So you can use a stack for a DFS. So, BFS works too. So I guess a DFS, you would just use a stack. So let's go ahead and try that actually, because I'm kind of curious now. So I'm going to do a stack. So let's do stack. So stack.pop, stack.pin. And it works. So let's go ahead and submit the DFS solution. And it's a bit slower, but it's the same essential thing. Okay, so that's the problem of the day for December 20th, 8:41. Hope you were able to learn something from watching me do this and going through kind of the methodology, goal, input, output, pseudocode, analyzing time complexity, space complexity, going through some examples, tests, edge cases, and then, of course, coding. Please leave a comment down below. Tell me what you think about the videos, what I can do to improve, and thank you for watching.